Welcome. My name is Carrie Donnelly, and I am the director of the Chapel Hill Analytical and Nanofabrication Lab, or CHANEL, at the University of North Carolina. Today, we will be talking about the electromagnetic spectrum. Most people are familiar with water waves or sound waves, but waves in the form of electromagnetic radiation are not as commonly known. One type of electromagnetic radiation you are already familiar with is visible radiation. This is what our eyes are sensitive to, and it's what allows us to see different colors. In this diagram, you can see that electromagnetic radiation has a wavelength associated with it. Visible light falls in the wavelength range between 400 nanometers and 700 nanometers. In this video, we will talk about the types of radiation that are commonly used to characterize materials. Many of you are also familiar with X-rays. If you break a bone or visit the dentist, you will likely have X-ray images taken. X-rays can travel through many materials, and they can be used to image bones in the human body. But you want to limit your exposure to X-ray radiation because it has much more energy than visible light and can cause damage to your cells. X-ray radiation has wavelengths from 0.01 to 10 nanometers. And they can be useful for characterizing materials. When you spend too much time in the sun, ultraviolet or UV radiation is what causes a sunburn. It also has a shorter wavelength than visible light, but it has more energy than visible light. In fact, it has enough energy that it can cause damage to skin cells. UV light can be used in a number of optical spectroscopies. Infrared radiation has longer wavelengths than visible light. Its wavelength can range from 800 nanometers to 1 millimeter. If you've ever felt the heat from a hot object, you've felt infrared radiation. It can also be used for material characterization. Visible radiation is the light we can see with our eyes in the wavelength range from 400 nanometers to 700 nanometers. It is used in a number of characterization tools, including light microscopy. Let's take a minute to talk about how visible light can be used for imaging. Many of you are probably familiar with a light microscope because it is commonly used in basic biology classes. A light microscope is made up of a light source, lenses to focus the light, a way to focus the sample in the light path, and a detector that is sensitive to the light, like your eye or a camera. Many of these same components are found in other microscopes as well. Here is an image that shows what can be seen on a light microscope. The RTNN logo in this image is about 1.5 millimeters wide, but the features within it are much smaller. Each letter at the bottom of the logo is about 50 microns wide. As you can imagine, light microscopes opened up a new way for people to look at small things. The human eye can only see things as small as about 0.1 millimeters, or the width of a human hair. Light microscopes allow us to see much smaller things. The best light microscopes can see things that are 0.2 microns wide. This is about 1,000 times smaller than what we can see with our eyes. Often, we will talk about the resolution of a microscope, which is the smallest feature that the microscope is able to image. There's a simple equation called the Rayleigh equation that describes the best resolution a microscope can achieve. It says that the resolution is equal to 0.6 times the wavelength of radiation, or lambda, divided by the numerical aperture of the microscope. The resolution is limited by the wavelength of light that is used. In theory, we could design a microscope with better resolution if we used radiation with a smaller wavelength. Thank you for joining me for this discussion of the electromagnetic spectrum.